Okay, quick video. We have this unit binormal, and I posed the question, what's the magnitude and the direction of the binormal? Okay? Relative to T and M. Now, you want to think that through. You really do want to think it through. So if you're watching the video, if you weren't in class today, you want to stop now and ponder this until you either see it or you end up putting a hole in the wall and beating your head against it all afternoon. Okay? What is T? It's a unit vector. Why is T a unit vector? Because it's obtained by dividing a vector V by its magnitude. If you divide a vector by its magnitude, you get a vector of magnitude 1. If you got a vector 12 units long, its magnitude is 12. And if you divide that vector by 12, you make it 1/12 as long, so it's going to be 1 unit long. That's a very fundamental concept, and what I'm seeing is people are maybe getting a little bit hung up on calculating, okay? Because, a typical response to this is, well, where's I, J, and K? How am I going to use the I, J, and K components? Okay, or well, here's how you do cross product of I, J, and K. But I, J, and K could be in any directions. Okay, X, Y, Z could be this way, this way, this way, this way, for the same motion. So if the motion's in this direction, my question is, what's the direction of your unit tangent at this point right here? Well, there it is. What's the direction of your unit normal? Well, you can see that the unit normal is perpendicular to this acceleration vector. So it's either in this direction or this direction. Okay. Perpendicular. Or, perpendicular could be out, in this direction or that direction also. Okay. Any direction around a circle here. But it's also going to be in the plane of motion. So if you're moving in this direction right now, curving inward, your unit normal is going to be inward, giving you centripetal acceleration. Okay? And your unit normal is a unit vector in the direction of A perpendicular, as we defined it here. Vector of 1 in the direction of your centripetal acceleration. The acceleration that's not parallel to your motion. Okay, then, again, what's the magnitude of B? Well, you have to do a little thinking here. And hopefully you thought it through, but think it through again. What's the direction of T and what's the direction of N? How do the directions of T and N compare? Well, T is here. Now N is going to be here. They're perpendicular, and they're both unit vectors. What's the magnitude of the vector you get when you do the cross product of two perpendicular unit vectors? Magnitude is going to be 1. And you have to have that intuitive understanding of the cross product. The cross product is maximized when two vectors, the magnitude of the cross product is maximized when two vectors are perpendicular. Because it's magnitude of this, magnitude of that, sine theta. Sine theta is maximized when theta is 90 degrees. Magnitude is also maximized if it's 270 degrees. Okay? In this case, we've got a 90-degree angle. Okay? So magnitudes are both 1, and sine of theta is 1. So magnitude of B is 1. Just like if you multiply the I by the J vector, you get the K vector. Why do you get the K vector? Because it's got to be perpendicular to I and J. And I and J are unit vectors that are perpendicular, so K has to be a unit vector. So we need to understand all that at the very basic level. So you can do with the I, J, and K vectors, but it's not relevant to the answer to this question. And if you're trying to answer this question using I, J, and K vectors, you're thinking of how it's calculated. And before you can calculate it, you've got to have a coordinate system. No coordinate system here. You could make one up, but it's not gonna help answer this question. The B is perpendicular to both T and N, and it's a unit vector. So now you've got your unit tangent vector, your unit normal vector, and your binormal vector. They constitute a perfectly good coordinate system. They're all perpendicular, and it's a natural coordinate system to use when you're analyzing the motion at this instant. So you've got these three vectors, okay? Trigger finger and that middle finger. There you got your three vectors, middle finger. You should be able to straighten it out, it's pretty curly. Trigger finger's getting better, but, okay, so here you are moving, okay? Now your binormal's moving, that tells you how the plane of motion keeps changing. Find an airplane, it's a good image to have, okay? And if you're trying to analyze motions in any way, it's a good image to have. So there's a coordinate system of unit vectors. It's almost like here's I, here's J, and here's K. At this instant, whatever coordinate system you started with, okay? So it's an important image. Now we'll build on this. And this is coming up in a couple of sections. I'm casting pretty well forward. But this whole picture of your unit tangent, your unit normal, and your binormal is really a key to understanding motion along the curve in 3 dimensions. Okay?